The question here is the ejection of the photoelectron from the silver metal in the photoelectric effect experiment can be stopped by applying the voltage of 0.35 volt. For that, you need to understand that there is energy associated with potential. So whenever we have some potential, means voltage is potential, there is some energy associated with it. And what this statement means, it means that if we have photoelectric effect and the electron gets ejected with some kinetic energy, okay, there is some kinetic energy with which it gets ejected. Question says that this kinetic energy can be nullified, can be reversed to zero by 0.35 volt per potential. It means the energy which is associated with this voltage is equal to its kinetic energy, because that makes the kinetic energy zero if applied in reverse direction. That is what it says. Stopped. Stopped means this much potential is applied in reverse direction, and the energy associated with this potential makes this kinetic energy zero. If it makes this kinetic energy zero, it means these both energies are equal. The energy associated with the voltage 0.35 volt and kinetic energy. So how you deal with it? Radiation is of 256.7 nanometer. From here you can calculate E. From this voltage you can calculate kinetic energy, because it makes the kinetic energy zero. So it is equal to opposite and equal to kinetic energy. The remaining is the threshold energy, work function. Work function is threshold energy. That is what you can calculate. We will say E is associated with the lambda given. When you substitute these values, nanometer converted to meter, you will get energy of the incident beam. This I have converted into electron volt, and there is reason, because I can convert voltage into its associated energy. Kinetic energy will be equal to the energy associated with 0.35 volt. If I apply a voltage V, associated energy for this one will be EV. So 1 volt will be equal to 1 electron volt in energy. This conversion you need to remember. From here, I calculated the kinetic energy. I know the energy, kinetic energy, work function will be the incident energy minus kinetic energy. Substitute the value. Any confusion? Let me know. This is actually physics. This is physics. Voltage and energy conversion is physics. So that is how you will get the answer. Everything clear? I'll move to next question then. Next question. And this one is very easy. You have the wavelength, yeah, and you have the velocity. Calculate the energy. So you just need to apply the formula, which is very simple. Okay. Which formula you will apply?
Wavelength equals to C by mv.
C by mv. Again,
Oh, sorry, sir. H by mv.
right, good. So wavelength is given here. Okay. Velocity is given of the ejected electron. So the photon of the wavelength strikes. So this is the energy E from here. Wavelength. So here you will not apply lambda equals to h by mv. Here you will apply E equals to E naught plus kinetic energy, half mv square. This is the energy with which the electron is bound to the nucleus. That is the work function. So actually read the question. You are asked to calculate the work function.
Sir, is this minus half mb square or plus half mb square?
Plus. It is plus. Okay. So question says you have photoelectric material. There is some wavelength associated with here, which is given 150 picometer. There is velocity given here 1.5 into 10 to the power 7 meter per second. This work function is the energy with which the electron is bound. This much energy you need to eject the electron. It means this is the energy with which the electron is bound to the nucleus. This one is required. Calculate the answer. Next question. Emission transition in Partian series and at orbit n equals to 3. And even if it is not written, you know that in Partian series, the transitions fall on n equals to 3 from any higher state, from any higher orbit at n equals to 3. And start from any orbit n. Now it is given that in this case, the frequency can be represented by this equation. In this case, this is Rydberg constant. Calculate the value of n if transition observed at this wavelength. Substitute the value. You know that nu is given by this one, which is given in the question. And nu can be written by c by lambda. This is the relationship. Nu is equal to c by lambda. Substitute the values and get the value of n. N you will get as 5. So it means transition is from n equals to 5 to n equals to 3.
सर 3.29 को सर राउंड ऑफ करके 3 ले सकते हैं.
No, 3.29 and 3, there is around 10% difference. You have formula for nu bar, but you can get formula for nu as well because nu is c by lambda and it is equal to c into 1 by lambda. It means nu will be equal to c into nu bar. So whatever formula you have for nu bar, if you multiply that by c, so you will get 3.29 into 10 power 15. That's what I am saying. If you didn't get that, I'm writing it. Nu bar is equal to 1.096 into 10 to the power 7, 1 by n1 square minus 1 by n2 square. Nu bar, basically you can write from here like this. So you can write here nu bar as mu by c, 1.096 into 10 to the power 7, 1 by n1 square minus 1 by n2 square. It means c will go into numerator here on right hand side. So you can write nu will be equal to c into 1.097 into 10 power 7 into 1 by n1 square minus 1 by n2 square. When you multiply these two, you will get this value. That's what I'm saying.
Yes, sir.
So in this case, Rydberg constant will be 3.29 into 10 power 15. So this formula sometimes in objective type questions in MCQ, it is very much applicable. You can use it. Okay. In 11th grade, this can be used if your teacher allows. This can be used directly to calculate frequency.
So the Redberg constant will be positive in this case.
Frequency is always positive. So Rydberg constant will be positive in this case.
Okay.
So how you have got this formula, that is I have explained, but you don't need to write this as the answer of this question because that is something given to you. You will just use it. You will write it. From lambda, you will get frequency because these are related. Nu is equal to C by lambda. You will substitute the value of C and the value of lambda, and you will get the value of N from here. The only unknown is N. And that is what asked, calculate the value of N. After that, it is asked, find the region of the spectrum. For that, you don't need to calculate anything because it is Partian series. Partian series has to be in infrared region. We will write it will be in infrared region. Next question. Calculate the wavelength for the emission transition of if it starts from the orbit having radius this much and ends at radius this much. So first convert these two same units. One is in nanometer, the other one is in picometer. So first you will convert both into picometer. So radius 1, this much picometer, radius 2, this much picometer. It means there is transition from some radius 1322.5 picometer to some other radius which is 211.6 picometer. The transition is from here to here. This is the transition, R1 to R2. And we know that these are interrelated with N. We have been asked, calculate the wavelength for the emission transition. These are related to N because the relationship is R1 equals to 52.9 N1 square by Z. This is R1, okay? Relationship you know in picometers, okay? So you will form two equations. Remember, we have to find the wavelength. For wavelength, what we are trying to do, we are trying to find out the actual orbits. Actual orbits we can get by dividing 1 by 2. If we divide equation 1 by equation 2, we get N1 square by N2 square by equals to 6.25. We take a square root. N1 by N2 will be 2.5 and 2.5 in simple whole ratio will be 5 by 2. 5:2. It means the transition is from fifth orbit to second orbit. Up to here, it should be very clear what we have done. First, understand what is given and what we are trying to find. We have to find the wavelength. We cannot get wavelength unless either we know the energy or we know from which particular orbit to which other orbit the transition is. In this case, only radius is given. So if radius is given, related to radius, we have orbit. That's what we can get from radius. So we have got the orbit number for both. Once we have this orbit, that is N1 is 5, N2 is 2. Now we can get wavelength and then we can name the series. And name the series, whenever if the question is name the series, it will be always based on that orbit which is lower. Because transition will always be from higher energy state to lower energy state. So series is always defined by the lower orbit, not the higher orbit. Okay. For example, Balmer series, all transitions from higher orbit will be from higher orbit to 2, n equals to 2. Partian n equals to 3, like that. Okay. So now you have N1 and N2. Here, remember, in case of this wave number, N1, this one is always less than this because we have to have wave number as positive. Number cannot be negative, it has to be positive. So from here, we get the wavelength, 434 nanometer. Once we have N1 and N2, we can calculate wavelength. Now the question was, another one part, second part, name the series which this transition belongs to. The series will be based on the lower bound, and lower orbit is 2, so it will be Balmer. When it is Balmer, it will
So
be
visible
visible. Try to understand what we have done. If any point is not clear, let me know.
Sir, here initially you said divided equation 1 and 2, sir, but what if we had calculated the value of n1 and n2 separately, sir, by by rooting the equation, the square root? So would
You
it
can't,
be
you
correct?
can't, because it is not given that this is hydrogen spectrum. There is Z, but the atomic number has to be mentioned.
Okay, sir.
Next question. The velocity associated with a proton moving in a potential difference of 1000 volt is this. The velocity is given, potential difference is given. If the hockey ball of mass 0.1 kilogram is moving with this velocity, calculate the wavelength associated with this velocity. Now here, what for it is given? Can anyone tell me whether there is any use of this? Whether there is any use of 1000 volt in this question?
We
No,
can
sir.
also.
Hmm?
No,
No, sir.
Right.
Sir, we'll simply put the formula for wavelength.
Right. Question is, the hockey ball of mass m is given. Okay. Is moving with this velocity, means this same velocity is given, 4.37 into 10 to the power 5 meter per second. Calculate the wavelength, and you know the relationship, de Broglie's equation. So there is no use of this voltage given here. You just apply the de Broglie's formula and get the answer.
so then why was it given in the question?
That's something, yeah, I still don't know why it is given. Might
Okay.
be that,
So probably to deceive us.
yes, just maybe to confuse you. It is not required at all.
So if we would have to find the kinetic energy, then we would find with the potential difference.
Yes, in that case, if it is reverse potential, then if in that case, it will be specifically written that the velocity of the ejected electron can be made zero by applying that much potential. By simply saying that this is the potential, it means this is the energy. This much electron volt is the energy. This is E, not kinetic energy. In this case, this is the velocity associated with a proton. So we can't say that this is, something uh, kinetic energy or something. This is energy related to this voltage. So if it is asked what is the energy of this particular proton, you will say energy will be 1000 electron volt. That's what you can say. No other information is given. Okay.
Okay, sir.
Proton is not related to photoelectric effect. So here it is just energy, nothing else. Next question. If the position of the electron is measured with an accuracy of it is plus minus 0.002 nanometer, calculate the uncertainty in the momentum of the electron. Suppose the momentum of the electron is given by something. Is there any problem in defining this value? So first part is very easy, because you know that uncertainty in position is given, and uncertainty in position is delta x, which is given as 0.002. Nanometer. So from here you can apply the formula delta x into delta p equals to h by 4 pi. So delta p will be h by 4 pi delta x, and you can substitute this value of delta x. And substitute these values. Make sure that you convert this to meter, and you can substitute the value of h, pi, etc., and you will get the uncertainty in momentum. Uncertainty in momentum is asked, you will get that. So I have not calculated that here. You can substitute the values and get the answer. Now come to the second part, and second part is very confusing. And basically this question has not been written correctly in NCERT. It is written in this way. It looks like that 0.05 nanometer, this 0.05 is probably in numerator. It looks like that. And nanometer looks like the unit of momentum. This question says, suppose the momentum of the electron is this much. This value is given. Momentum is this much. So if momentum is this much, it looks like that probably we are saying the unit of momentum is nanometer,
Sir?
which is not there. Basically, this part, this whole part is in denominator.
So I think 0.05 is multiplied with whole of h upon 4 pi.
No, it
No,
is in
sir.
the
I think
denominator.
it represents delta x, sir, 0.05 nm.
It is actually h by 4 pi, and this m should have not been here. There is no significance of this m. This is just creating confusion. Into 0.05 nanometer. It is similar to this one. Now compare these two. So there should have been a bracket to show that the entire of 4 pi into 0.05 nanometer is in the denominator. So this is how you will treat this question if it appears in your examination. So this is like this. So question is, suppose the momentum is given, means it is not the uncertainty, it is actual momentum is given p, not delta p. Momentum is p. So the question is there any problem in defining this? The answer is yes, there is problem. And the problem is, if I have uncertainty in momentum as this much, okay, and the momentum itself is less than this one. Why it is less than this one? Because 0.05 in the denominator is greater than 0.002. So if denominator is greater, it means P will be smaller. Delta P will be larger. This is small. So if the uncertainty is larger than the value itself, then there is no significance of defining it. It cannot be defined like that. It is something like that I am at a distance of, say, I am from my initial position, I am at a distance of 1 kilometer, and the uncertainty is 10 kilometers. Does that make any sense? If I say I am at 1 kilometer and uncertainty is 10 kilometers, means I can be at -9 kilometer, that is on
No,
left
sir.
side, or at 11 kilometers from the starting point. It doesn't make any sense if uncertainty is greater than my actual value. So you will say, as the potential momentum, as the momentum itself is much less than the uncertainty, it cannot be defined. That's how you will write it. Okay. This uncertainty in momentum is much greater than the momentum given. Hence, it cannot be defined. As I gave you example, uncertainty you can consider is 11 or 10 kilometers, and actual is 1 kilometer. So there is no sense talking such values if I am at 1 kilometer and uncertainty can be 10 kilometers. Anyone not clear? Next, the quantum numbers of 6 electrons are given below. Arrange them in order of increasing energies if any of these combinations have or has the same energy list. The energy is given by n plus L value. You will write it in exam. If this question appears, you will write energy is given by n plus L value. So here you will say energy is given by n plus L. So in first case, it is 4 plus 2, 6, 3 plus 2, 3 plus 2, n plus L, 5. Then you have 4 plus 1, 5. Then you have 3 plus 5, 3 plus 1, 4, 4 plus 1, and 1 and 4, L1, 5. The second part is if any combination has or have the same energy list, so you will list these have energy equal to 5. Okay. So 2, 3, 4, and 6 have same energy. In this case, don't say that and will decide the energy. So that is not, this question is not talking about filling up of the electron. This question is talking about only energy. Three plus 2, 5, 4 plus 1, 5, 3 plus 2, 5, 4 plus 1, 5. Next.
So what is the reason in question number 62 that these are
That
same energy list?
because energy is defined by n plus L value. If
Okay.
n plus L value is same, so here in this case 5, 5, 5, 5. Values are same.
The need of orbitals and spin was not needed.
No, energy is decided by L number and azimuthal quantum.
Sir,
Quantum number and azimuthal quantum number only. Mainly
sir,
by
what
use of
about the number third and sixth, sir? They are absolutely same, sir.
yes, these can be marked. Might be that here in question it was minus, might be, but that will not make any change
Okay, sir.
because it is defined by n plus L value only. Next question. The bromine atom possesses 35 electrons. It contains 6 electrons in 2p orbital, 6 electrons in 3p orbital, and 5 electrons in 4p orbital. Which of these electrons experiences the lowest effective nuclear charge? We discussed about it. I have got, okay. Yash Bedi has raised hand. Avish has raised hand. Yes, Yash, tell me the answer.
So, I think, sir, it will be 4p as it is the outermost chain.
Okay. And what is the reason? Other than it is outermost, what is actual reason?
Sir, it is because of the screening effect due to inner electrons.
Good. It is actually the shielding effect or a screening effect due to which the 4p will have the lowest effective nuclear charge or highest shielding. Highest shielding will lead to lowest effective nuclear charge. So understand what I am saying. It is 2p. So 2p will be like this. Okay. Then 3p. So 3p will be like this. And then 4p. 4p will be again evenly. So
So the
4p,
more the value of n, the more the low effective nuclear charge.
yes, correct, correct. So here in 4p, electron can be and will be mostly away from the nucleus. And if it is away from the nucleus, the electrons which are here in between, these electrons will shield, will be between the nucleus and the outermost electron. So they will shield. The force of attraction will decrease. Why it will decrease? Understand it in different way also. Let's suppose you have s electron here. Say you have 4s electron. So 4, say this is 4s. So electrons will be here, 2 electrons. When this electron comes in between the nucleus, this is nucleus. So it comes in between the outermost electron and nucleus. So it creates hindrance, first of all, due to hindrance. Second is that this is negative. This is also negative. So this will repel each other. It will repel. These two electrons will repel each other due to same charge. So if it is repel, the force will be on the outward side. It means effective attraction force will decrease. So say force of attraction was 10 units and due to repulsion there is 1 unit. So effective is 10 minus 1, that is 9 units only. So two reasons there. First reason is it is in between the two species. That's why there will be decrease in force of attraction. Second one is there will be repulsion, which will result in less force of attraction. So these two factors result in shielding effect. 4p is the correct answer.
Sir, I have one doubt, sir. Will the size of 3p orbital be bigger or 4s orbital, sir?
3p is bigger than 4s. Like
Sir, on what grounds do we decide the size of the orbital, sir?
Schrodinger has decided that we can't decide that.
Okay.
It is based on the solutions of Schrodinger wave equation. Among the following pairs of orbitals, which orbital will experience the larger effective nuclear charge? The answer here is again easy. Okay, this time I'll give chance to Kavish. Yes.
Sir, in the first pair, 2s will experience larger nuclear effective charge.
Right.
And in second, sir, should I tell all of them?
No.
Okay,
First
sir.
one is correct. Second, Kartike.
Sir, in second, 4D will experience larger effective nuclear charge.
Okay, good. Next, Arna,
Can I?
third one.
Sir, 3p will experience more effective charge,
Right.
nuclear charge.
The rule is simple that larger the distance, okay, larger the distance from the nucleus, less effective nuclear charge. So these are closer. This is closer, and this is closer. P is smaller than D. S is smaller than P. P is smaller than D. D is smaller than S. So that is the rule. So smaller ones will experience greater effective nuclear charge. Good. Next, the unpaired electrons in aluminum and silicon are present in 3p orbital. Which electron will experience more effective nuclear charge from the nucleus? Here it is same. The orbital is the same. In previous questions, orbitals were different. Who will answer the question? Okay, Pranav and Kavish. Karthikeya also. Okay, Pranav, yes. Tell me the answer.
Sir, the unpaired electron in Si will experience more effective nuclear charge.
Okay, why?
Sir, because its atomic radius is smaller.
The silicon has greater nuclear charge than aluminum as the unpaired 3p. Now, the reason is very much what Pranav said, that but slightly different. So that's something I'm looking answer from others also. If you could explain why the answer is silicon, it is slightly different. So that's why I'm asking. I am asking for the reason. Silicon has greater nuclear charge. That is fine. Reason. Karthikeya, yes.
Sir, because silicon will have more number of protons.
Okay. Yes. Okay. It is fine what you are saying, but because silicon has more number of protons, that is correct answer, because when you move down the group, okay, it will be across the period, the radius will decrease. But what is the underlying reason? The underlying reason is the increase in the number of protons. So that's why greater force of attraction. I'm just explaining it. So you have 1, 2, 3 shells in aluminum and 1, 2, 13, 4. Okay. But here you have, it means 13 atomic number. Here you have 13 protons. Here you have 14 protons. So it means plus 13 charge. Here you have plus 14 charge units. So force of attraction with the valence electron will be higher here due to 14 protons in the nucleus. So that's why greater nuclear charge. Next question. Indicate the number of unpaired electrons in phosphorus, silicon, chromium, iron, and krypton. You will write the outermost electronic configuration. Phosphorus is 15 electrons. Atomic number is 15. So if it is 15, you will write 1s2, 2s2, 2p6, 3s2, 3p3. 15 electrons total. So 3p3, if you see, has less than maximum electrons, and as per Hund's rule of maximum multiplicity, each orbital will have 1 electron. Pairing will take place after all orbitals are half filled. It means there will be 3 unpaired electrons in this case. Now silicon 14.
Sir, 2 unpaired electrons.
Yes. So here you will have, instead of 3p3, you will have 3p2. Means 2 unpaired electrons. Chromium. Who will tell me the answer?
So may I?
May I?
Sir, may I?
Okay. Raise your hands. Okay, Pratyush, yes, tell me the answer.
Sir, 6.
Okay, 6. Anybody who says Not 6. Okay, lower your hands. 6 is correct answer, because in chromium, one electron moves from s to d orbital to have half-filled configuration, more stable configuration. It is exception, if you remember, 24. So it was in normal case, which is actually wrong. It would have been 4s2 3d4, outermost electronic configuration with 24. But in reality, one electron from s moves to d. The 2 electrons are here. 4 electrons are in d, but 1 electron moves to d, so that it is half filled. S is half filled, d is half filled. It will actually be 4s1 3d5, total 6 unpaired electrons. Next, iron. Iron atomic number is 26. So 26 will be 1s2, 2s2.
Sir, there would be 4 unpaired electrons.
Okay. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 10, 10, 20. Okay, 26. So here in D you have 6. So 5 electrons will be filled 1, 1, 1, 1, 1, and after that pairing will start. So there will be only these 4 electrons which are unpaired.
So,
Yes.
so in exam, if like in the paper it comes like to write electronic configuration of any element. So like, so can we first write the like the name of the nearest noble gas and then
Well, that is not required, because if it is say iron, iron is just in between, middle. Manganese in middle. So there is no reason you should be first writing. What you are saying, that if it is very lengthy, do
no
you
no
mean?
yes sir, yes, जैसे 26 है तो सर हम पहले neon का लिख के उसके बाद
Then you can write. Yes, if it is very lengthy, then you are saying previous
Yes, sir.
neon, right? Yes, in that case,
yes.
that is possible. Now, krypton itself, you should first know that this is noble gas configuration.
Zero. It will have 0.
Zero. Good. Noble gas will not have any unpaired electron. That is zero. Now, the last question. How many subshells are associated with n equals to 4? Quite a few such questions we have done. Okay. A part. Who will tell me the answer? How many subshells are associated with? And you need to tell me the names also.
May I?
Subshells. Okay, I'll give chance to Subway.
Yes, sir. So it will the range is from 0 to 3. So the subcells are S, P, D, and F.
Right. So for n equals to 4, it will be from 0 to n minus 1. That is 0 to 3. 0, 1 to 3 means S, P, D, F. So you need to write 4S, 4P, 4D, 4F.
Okay, sir.
Yes, Arna, correct answer. Okay, next part. Who is going to tell me the answer? How many electrons will be present in the subshells having ms value of -half for n equals to 4? Okay, Lemuel, yes, tell me the answer.
Sir, 1 electron.
Okay.
Sir, can I?
Azan, tell me the answer.
Sir, 8.
No. Amir, tell me the answer.
Sir, 16.
Okay, how?
Sir, in the and in n is equal to 4, there will be 2n square, so there will be 36. But for minus half, there will be half of that.
Sir, 18.
Okay. Who said 18? Okay. Well, 38 or 18, I give chance to Arna.
So 16.
Okay, how?
Sir, n equals to 4 and the number of orbitals in the nth shell is equals to n square. So 4 square is equals to 16.
So may I?
Just a second. I closed it. So who said may I?
So Yash Bedi.
Okay, Yash, tell me the answer.
The answer is 16, sir, because in the fourth subshell, the number of electrons is equal to 2n square, 32, and the number of electrons having minus 1 by 2 spin is 16.
Okay, correct. You know, Amir's answer was also almost correct, but 2n square value, he said 36. Okay, that's why.
तो मैंने गलती से बोल दिया, sorry.
All right, okay.
But
So
n square होता था ना formula तो.
electrons, that is number of orbitals. Here electrons is asked.
Yes,
Okay,
sir.
One orbital has 2 electrons, so that will be 2n square.
Okay, sir.
The number of electrons in nth shell, 2n square. In fourth shell, total number of electrons will be 2 into 4 square. 16 into 2, that is 32. Then you will say electrons with minus half spin will be just half. 32 by 2, 16. Half will be with plus half will be with minus half. 16 will be the answer. Any confusion?
So 32 by 2 does 16.
Yes, 32 by 2. We will say 16. That will be the answer. Now, I think this was the last question here. In NCRT, there are 67 questions only. So if there is anything related to what we have done and you have confusion, just let me know. You can ask.
So,
Yes.
so like in the formula of Heisenberg's uncertainty principle, sir, हम ये कैसे पहचानते हैं कि किसी का wave character है या नहीं?
Okay, that is basically based on the value. Basically, if you see, I write the formula and it will be clear. If uncertainty is very low, we will say particle nature prevails. If you can calculate both position and velocity accurately, so I'm writing it. If both position and velocity. If both position and velocity can be calculated accurately, then particle nature prevails. That is, delta x tends to 0 and delta v also tends to 0. And here I am writing and, not or. Okay? Delta x and delta v both tend to 0. That's why you can calculate both. It means the value here will be very small. you will. So if you get
Sir,
the
you mean below 10 to the power minus 4? Where sir said this thing.
Yeah, you can, I will tell you, okay? I will tell you how. So for example, you consider only just 100 gram ball or 1 gram ball, just 1 gram, okay? So even if you have for 1 gram, delta X into delta V will be 6.626 into 10 to the power minus 34 divided by 4 into 3.14 into 0. Or you can say 1 into 10 power minus 3 kilograms. That is 1 gram. So what you will get? You will get of the order of something into 10 to the power minus 31 is still, okay, or minus 32 like that. And this is very, very small value. It means both of these two can be small. Their multiplication is very, very small. So if the product of delta X and delta V or delta X and delta P is very, very small, particle nature prevails. If this is a large value, it means either delta X or delta V can be made small, not both. Okay, not both. So for example, delta X and delta V are 1, say, okay. Then you can say if delta X is very small, say 0, 0, 1, then what will be delta V? Delta will be 1 divided by 0 0.001, 0.001. That is 10,000 meter per second. Uncertainty in velocity is that high, 10,000 meter per second. Then it will be wave nature.
Okay, sir.
Why wave nature? Because it will be possible only if mass is very small. So understand what I'm saying. The product of these two can be very, very small only if mass is very small. Sorry, very large. So this will be large. Now I'm not considering the particle nature, I'm considering wave nature. So if it is wave nature, means the mass of the particle will be negligible. That's why it will act as wave. So if this one is very small, mass is very small, say of electron, and this is say 9.1 into 10 to the power minus 31 kilograms, and H is 6.626 into 10 to the power minus 30. Now this value, if you calculate, will be of the order of around 0.01 or so. Okay, 0.01 or 0.001. Now you can't have delta X and delta V both very small because the product is 0.001. They both can't be very small. If you try to reduce one, the other one will increase. Do you get it is math actually what I am explaining? Are you able to understand what I am saying?
Yes.
So the condition which you will use in Heisenberg's uncertainty principle, if the product of uncertainty in position and uncertainty in velocity is very small, then particle nature. If it is high, wave nature.
Okay, sir.